Moving on to lesson 5.3, which we did on Friday. This is going to involve binomial random variables. It's just a special kind of random variable. It has its own properties, but it really follows all of the rules for binomial distributions that we've seen already. But it's going to involve some special calculator things, so let's roll forward. Here, the question is, can you pass a quiz without reading the questions? So you're going to get a quiz, not really. We hope you're ready. A quiz consists of 10 multiple choice questions. Each question has 5 answer choices. Now for the bad news. You'll not get to see the questions. You'll just have to guess the answer to each one. What are the chances that you're going to pass? Well, passing would be 7 out of 10. That's going to be really remote. What would be even more remote is to get a perfect paper on it, which would be all 10 out of 10. But we're going to see these things. So if each question contained 5 possible answers, then you would have 1 correct choice and 4 incorrect choices. So that's 1 out of 5. The probability of success, which they have right here, is 0.2. That's 1 is 20% of 5. Or 2 is 20% of 10. 2 over 10 reduces to 1 out of 5. So we're going to go to the Staplet app, and we're going to look for binomial distributions. So here's the browser, and you can put in that address or just do a search on Staplet and Staplet statistics, and it comes right up. We want probability. We did the discrete random variables already. We will be doing normal distributions. We're looking at binomial distributions. Okay, so it opens up to this. And by the way, this would be a good thing for you to use because you can do some things here that I'm going to show you how to do on the Nspire calculator. And if you don't own one of those, this would be a good second choice. In this case, n is going to be 10. And the probability of getting one right would be 0.2. And I guess I picked a comma here. Let's change that to a period. So 0.2. And let's just look at the distribution. There it is. It looks just like any old random variable probability distribution. The values for x are on the horizontal, 0 through 10. And the probability of each is extended on the vertical. And you can kind of see that the probability here is kind of clustered around 2. Because if you think about it, if you have a 20% chance of getting any question right and you do 10 of them, you would expect to get 2. Another way to describe this would be to look at its shape. It does go from 0 to 10 because you have 10 questions. So if you follow it along, it is pretty wildly skewed to the right. So skewed to the right, and it does give you the mean and the standard deviation. And there are different ways of calculating the mean and standard deviation. We won't be really looking at that today, probably on Monday. So here it is. If we want to calculate the probability of exactly, let's say 4, and I use that because it will be asked, what would be the probability of getting 4 right out of 10? And that would be right here. That would be about 8%. Let's head back to the sheet and what's next. So they dropped in the histogram. We didn't draw it in class as we have not been doing because of the time factor, but I'm sure that you could copy that onto paper. So it is skewed right. And if we were going to use this histogram to estimate the probability of guessing exactly 4 questions correct, what they're saying here is if you read from the top of this 4 bar over, it is kind of around 10%. I'm seeing less, and we did get like 8%, almost 9%. But if you were to just quickly eyeball it, 0.1 or 10% would be good. All right, so then it says use a formula to find the exact probability of guessing 4 questions correct and use the applet to verify the answer. I think we already did that. So here is, these are 2 ways to get this answer correct. One of them is with a formula, a formal formula, and it consists of 3 parts. It consists of combinations of 10 things taken 4 at a time, because you could get all different arrangements, or I don't want to say arrangements because that's permutations, but you could get all kinds of different groups of 4 out of 10. It could be the last 4, the first 4, the middle 4, any set of 4 out of 10. So we need the total number of that, times the probability of success, which is 0.2, but it's raised to the k power. So this 4 and this 4 are the same. Then it's also, as a third thing, times the probability of failure. So failure and success are complementary. If the probability of success is 0.2, then the probability of failure will be 1 minus that, or 0.8. And that'll be raised to an exponent, the n minus k power, or 10 minus 4 is 6. All right, so here it is, the combinations, and I'm going to show you combinations on the calculator in a kind of easier way, but they do come to 210. Then 0.2 to the 4th is 0.0016, and then 0.8 to the 6th is 0.262144. And if you multiply the 3 together, you get exactly what we saw in the applet. Another way to do it is that your calculator not only can do combinations and permutations, which I'm going to show you those, but it can also do, this is going to be called a binomial distribution. And the reason it's binomial, bi meaning 2, is because there are 2 things that can happen. You either get a question right or you get it wrong. When you see that kind of an arrangement, that's going to be binomial. There's some other parts of it. There's 3 other rules that you have to meet, but the major thing is the success or failure. There is a feature in your calculator, and it's menu 6.5a, and it's binomial PDF. PDF stands for probability distribution function, and you put in the number of trials. In this case, it's 10 questions, probability of success, 20%, 0.2, and how many you're interested in getting the probability of getting right. Here it's 4, and it's the same answer as this. This is just rounded version of this. Let's go ahead and peek at the calculator. If you happen to have this handy, if you own one, you can play along. Otherwise, just kind of memorize how it works, and we'll see how it goes. Okay, so let's start out with that first formula that had the combinations and everything. I never showed you this in chapter 4 because I didn't think we were supposed to, but now that we're out of chapter 4, let's go ahead and look at how combinations and permutations are done. So I'm going to go ahead and just work on a calculator page. I'm going to do menu and probability. Oh, and looky here, combinations, permutations, factorials, all those things were already here. So let's do the combinations. So when I choose this, it doesn't come up the way we typically write it. We usually put n in front and k or r second, but we just have to put them in the correct order. So it's going to be 10 things, comma, 4 at a time. Then let's get out of here. And that's going to be times the probability of success, and that'll be raised to the k power, that'll be 4. Get off of the exponent, so right arrow off, and then that'll be times the probability of failure, 0.8, and that'll be raised to the n minus k power, which would be 10 minus 4, or 6. All right, and that's everything. It should give us the right answer, and boom, right answer. Nice, nice. So let's go ahead and see the other way that the calculator can do it. That will be under menu. Remember, it was menu, and then 6, and then 5 for distributions, and then we had to pick the letter A because they actually ran out of digits. There were so many operations under distribution, so we're going to pick binomial PDF. And the nice thing about it is it comes up with this little input screen that tells you exactly what to put in. So number of trials is 10, tab. Probability of success is 0.2. and then we'll tab the value for x. That's the value of x that we're interested in getting the probability of. That would be 4. Tab down to OK, and there it is. And what's even nicer is we can do a little bit more exploring. I'm just going to go up, and select what I just put in and hit enter so I don't have to put it in again. And I'm going to change this 4 to a 7 because remember 7 was passing. So I wonder what the probability is that you would get 7 out of 10 right just from guessing. And that would be, let's see, that's tenths, hundredths, thousandths, 10,000. That's 7 out of 10,000 times that you try it. That's not very likely. What's even worse is if we try for a perfect paper. I'm going to go in here, delete the 7, and type in 10 out of 10. Watch out, it's not going to be pretty. Here it is. That's a whole lot of zeros. Okay, in fact, that is so close to 0 that it's clearly not worth trying it. However, if your life depended on it, the probability is not quite 0. You know, if you believe in MacGyver and miracles, then you could try it. But I would bet against it, frankly. So there's your calculator. We're going to look now at binomial a lot more closely. Okay, the learning targets are up now. Learning target number 1 is to determine whether or not a problem that you're working on is going to be a binomial setting. Typically, what I do is if I get a weird kind of probability question, I just stop, take a breath, and say, is this success or failure? Do I pass the test or don't I? Do I win the race or don't I? Whatever you're interested in, it either happens or it doesn't. So that would be the success or failure. So we're going to use an acronym that's using the first letter of things to create a word to give you kind of a hint about what the word stands for. So B is for binary, either success or failure. I is independent. Okay, I almost never run into an issue where there's a problem with independence. Basically is what you just did, is that going to impact what you're about to do? And typically it's almost always no. I've never really had to walk away from a binomial setting because of lack of independence. I suppose it could happen. All right, N is a set number of trials. Okay, we had a quiz with 10 questions. So that's 10. N is 10. And S, that's the same probability of success on each trial. In that case, for the quiz, since you were guessing, you had a 20% chance of getting any one of those 10 items right, just by luck. So this all forms the word bins, and that'll help you when you're asked, does this fit a binomial setting? You're going to have to check all 4. And you may forget some of them, and the word bins can help you remember. Learning target number 2 is to calculate probabilities involving a single variable of a binomial random variable. Okay, on Monday we're going to look at, more than one. Sort of like at most this much, or at least this much, or 4 questions, or 5 or 6. It's anywhere from 4 to 6, that's more than one. But for today we're just going to look at the probability that x equals a certain number. So we had this formula. It was made up of combinations times the probability of success to the k power, same k, times the probability of failure to the n minus k power. So n is the total number of trials, k is the number of successes, p is the probability of success, and q is the probability of failure. Q is going to be equal to 1 minus p. Okay? So remember p was 0.2 in the previous example, and the q was 0.8. Those two things have to add up to 1, p and q. Or you can do the n-spire, which we showed on the front. That's menu 65A. That'll give you a binomial PDF, and you input the total number of trials, probability of success, and x are the number of successes you want to generate a probability for. Okay, So you have both of those choices. My choice would be the binomial PDF. It's just easier. All right, and the third learning target is to make a histogram to display a binomial distribution and describe its shape. All right, it was the same as the previous lesson. Build a histogram. The values of your random variable go on the x-axis, the probability on the y-axis. Then you can draw the histogram. You don't need to go and actually generate it, using the calculator, although I will show you how to do it. All right, and then describe the shape, skewed left, skewed right, and that would be either symmetric or uniform, any one of those. Okay, so here's your application. Is the train binomial? According to New Jersey Transit, the 8 a.m. weekday train from Princeton to New York has a 90% chance of arriving on time on a randomly selected day. Suppose this claim is true. This is something we saw earlier. It's the very same scenario. So look, it either gets there or it doesn't on time. All right, P is going to be 0.9 and N is going to be 6. Choose 6 days at random. X will be the number of days on which the train arrives on time. Number one, here is why this is a binomial setting. It is binary because the train is either on time or it's late. That's your success or failure. Independent? Probably so. Yes, one day does not affect the others. Set number of trials? N is 6, so big yes on that. And the same probability of success on each trial, yes, P equals 0.90 each day. Okay, so calculate and interpret the probability that X equals 4. All right, here is what we would do in the calculator. So let's just go ahead and go back to the calculator, and I'm just going to clear this out. So let's see, menu 1.5 will do it. And we'll start out with the combinations. That was 4 days, I believe it was. Let's just double check that to make sure. All right, probability that X equals 4. Okay, so we'll start out with combinations. That'll be menu, probability, combinations. In this case, N is 6 and X is going to be 4. And that's going to be times the probability of success, which is 0.9, and that'll be raised to the k power, that's the 4. And then that'll be, we'll get out of there, and times the probability of failure, 0.1, and that'll be raised to the n minus k power, which will be, in this case, 2. So let's see. Okay, we have this about 9 or 10% of the time. Let's check it using the binomial PDF function. So back to menu, and then statistics is 6, and we want distributions, which is 5, and then binomial PDF, which is A. All right, number of trials was 6. The probability of success was 0.9, 0.9 if you will, and we're interested in 4. And we should get the very same number we already got. So we'll enter that. Bingo. Great. Let's actually also go ahead and do this on the Staplet, which I believe I still have open. And all I need to do is change what my N is. That would be 6. Let me find 6. And we'll change the probability to 0.9. And we'll plot it. Okay, it should come as no surprise that this is going to be skewed madly to the left. And the reason being is because the trains are very likely to be on time. So having all 6 be on time, having 5 out of 6 be on time are the two most likely things. Now, if we were to change this to late, and I just went ahead and deleted that and made it 0.1 because it has a probability of being 0.1, let's see what will happen. Just go ahead and plot it. Oh, it flipped over because there's very little probability of these things being late. Does that make sense? Okay, So we can also check, and I guess I need to put this back to 0.9, so let me go ahead and do that. And we'll put it back to the way it was and calculate the probability of exactly 4. And let's see if I can get that to go in and just hit go. It is about 9.84%, or as we had before, 0.0984, same thing. All right, so make a histogram of the probability distribution of X. That's what we did. It would need to be copied here. It is skewed to the left. I believe I said I was going to show you how to do this on the Nspire. There are actually a whole lot of steps. It's kind of complicated, so I think I'm going to pass on that, and we'll just go ahead and rely on the Staplet if we need to see something like this. There it is. We're done. Thank you for watching. I hope this will get you caught up.